In this video, we're going to work through an example of finding the difference quotient for a given function. Let's suppose we have this function. F of x is equal to 2x squared minus 3x plus 5. I want to evaluate the difference quotient, which is f of x plus h minus f of x divided by h. So there are three parts to this process. The first part is to express f of x plus h. The second part, subtract f of x. And the third part, divide by h. Here's my objective. Get h out of the denominator so I can effectively let h be 0, and I will have a formula for the slope of a line at one point. So the first thing I'm going to do is to take my function, and I will evaluate f of x plus h. And that means wherever I have an x, here and here, I will replace that with x plus h. It will look like this. 2 times x plus h squared minus 3 times x plus h plus 5. Now that's this piece of the difference quotient. That's f of x plus h. I replaced x in the two locations where it occurred with x plus h. The second part now is to subtract the function. Here's my function. I'm going to subtract that function minus parentheses 2x squared minus 3x plus 5. And this is all divided by h. Well, I'm going to do the algebra and simplify what's in the numerator. So remember here I have to FOIL x squared plus 2hx plus h squared. Distribute negative 3, negative 3x, negative 3h plus 5. Distribute negative 1, negative 2x squared, positive 3x, negative 5. I'll come back here and I'll distribute the 2, and if it's okay with you, I'll just do that right here. So I'm distributing 2. So I would have 2 times x squared would be 2x squared. 2 times 2hx would be 4hx. 2 times 2h squared would be, or 2 times h squared would be 2h squared. And this is all divided by h. Now if we did our job, and we did not make any mistakes, all the terms in the numerator that do not contain a factor of h will factor out, leaving only terms with a factor of h. We're going to factor that h out of the numerator, which will factor the h in the denominator, and hence we'll have an expression for the slope of a line at one point, which in calculus we call the derivative. Let's go. So notice what's happening here. 2x squared, negative 2x squared. That's got an h, that's got an h. Negative 3x, positive 3x. That has an h. Positive 5, negative 5. The remaining terms have a factor of h, which I will take out of that numerator. I'm going to factor out that h. So here I'm left with 4x. Here with 2h. Here with negative 3. Divided by h. And I'm lucky, and what I wanted to happen has happened. H is now removed, and what I have here in this expression, 4x plus 2h minus 3. This formula is the difference quotient. This formula gives me the slope of a line when I'm given a point, x1, xy, if you will, and the distance h to a second point. I would place the value of x here and the value of h here. What I get will give me the slope of a line through those 2 points. If I'm working with 1 point, h is effectively 0. And so if h is effectively 0, this simplifies to 4x minus 3. 4x minus 3 is the derivative for this function. I'm going to write that up here. 4x minus 3. That tells me the slope of a straight line to this function when I only have 1 point, which is pretty cool. That's the instantaneous rate of change. What can I do with that? Well, let's think. I know the graph of 2x squared minus 3x plus 5 is a parabola. I know that parabola opens upward, and it would look something like so. Now, of course, it would be graphed on an axis, but I know it's basically a U shape. What do I know about this function? Well, at its vertex, at its turning point, the tangent line would have a slope of 0. This formula tells me the slope of a line at 1 point. So if I take this formula, 4x minus 3, I set that to 0 and solve, it tells me that x is 3/4. And that 3/4 is the x-coordinate of the vertex. This point, the x-coordinate is 3/4. Again, that's where the tangent to that parabola is 0, has a slope of 0. Pretty cool. Now, if this were a cost function representing your units to produce and the associated cost, you would want to produce at this level of output because that level of output would give you minimum cost. So here's an example of taking a function and evaluating the difference quotient and seeing an example.